Today, we're demonstrating VIA AIOps Signal Onboarding process. VIA AIOps collects and enriches streaming data from devices, the network, and applications in real time. The onboarding process builds data models automatically with dimensions and data types. This simplifies and speeds the processing of data preparation, ingestion, and enrichment. Let's review the UI and see how this works. We use a third-party configuration like an SDD file from a configuration of a router, a Yang model, or by reading sample JSON records to create a dynamic schema. VIA interprets the data without the need to write code. Once the data is interpreted and the schema is created, the file is flattened and ready for a real-time parser to handle, interpret the code, or the live stream of data as it comes in. You can either upload source data or just point it to where that file lives. Once the data is captured, parsing can begin to interpret the schema and lay out all the dimensions of the data, the metrics, and the data types. These can be changed and edited if they have been interpreted incorrectly. You can also decide if the dimensions should or shouldn't be included in the record. Now you can see we've structured the data into something that can be analyzed. From this point, we can enrich the data with additional information. To do this, you choose another data source for enrichment. I can pick a data source and a reference schema here, or a reference table with the data source. Now I execute an outer join or an inner join to enrich the initial derived data. From here, we can derive other values or manipulate the metric itself. As an example, this is where we're picking this event name as the metric. This is what will be plotted on the time series. It indicates which one is the timestamp, the measure, and then the rest are allocated as dimensions of the metric. Again, you can override and select something else if it has not been interpreted correctly. The mapping is a simple way of explaining the data type. Is it an average, a gauge, a counter, or a continuous counter? You can set simple aggregation techniques. For example, if you want to set an aggregation of 5 minutes, you will set this and it will aggregate everything into 5-minute buckets. You can also handle late or out-of-order data by defining a time delay. If I have a 5-minute window, I can wait an additional 1 or 2 minutes in order to allow for out-of-order or late data to be included in that bucket. There is also a step window size. Do I want to look across 5-minute increments across a 1-hour time period? Or do I want to look at 5-minute increments discontinuously? This allows you to smooth out your analytics for things like sparse data and small counts. If I move to output, we can see if we need to do any manipulation. For example, if timestamps come in as a Unix time, you can add math functions in order to normalize the time across multiple datasets that have different times. You can also add regular expressions and other math functions if you need to divide milliseconds by 1,000 to come up to seconds, or if you need to divide a value by 100 to come to a percentage. You can also calculate across dimensions. This shows the various functions available. You have data references, date, time functions, and string functions. You have any of these math functions that can be applied to the measures themselves in order to create the actual metric values or KPIs that you want. Now, VIA will generate a systems model. I ask the system to generate the metric table, and then I deploy both the data model that I just created as well as the parser model. I can pick my source and then hit the play button to pull in sample data and test my model. After testing, I deploy the real-time parser model and bring in the data set. From start to finish, with a complete new data set that hasn't been seen before, this is usually done in less than 60 minutes without the need to write code, and it can be done in the field. With the ability to ingest and process metrics, traces, logs, and events, VIA handles fault, performance, and change management across service domains, automating workflows, and delivering measurable service assurance improvements. The result is a reduction in the overall cost of addressing performance issues and improving the customer experience by accelerating not only the time to detect issues, but to resolve them.